Today's live event was produced for the Connect Transform the Future program in collaboration with National Geographic Education and the Center for Science, made possible through the generous support of GE.
The world's demand for energy is constantly growing, so to keep up with that rapid rate of development, energy producers are expanding the use of renewable energy. We've all heard of that, right? Energy that comes from sources that are constantly replenished, like the sun and the wind. So as the renewable energy industry grows, so do its career opportunities. Do you think one of them could be the right fit for you and your future career? Well, that is the question that is on the minds of everybody today, and that's what we'll hopefully start to answer. Hi, everyone, and welcome to Jason Live. I'm Patty Kim, and I'll be your host today as we explore careers in renewable energy. And we have joining us in the studio Kathleen O'Brien. She's an electrical engineer, also manages GE's Power Systems Laboratory, which is a very intriguing sounding name. We're going to find out a little bit more about what Kathleen does in just a minute, but I wanted to remind you that first and foremost, today's program is live and interactive. So we really encourage you to submit your questions, participate in the polls, get in on this conversation. Ask Kathleen anything you want. Ask her all kinds of stuff. She's totally game. And we're so excited to have you guys with us, and we're so excited to have you with us. Thank you so much for stopping by.
Thank you.
So tell me, Kathleen, first of all, what do you do? And how does that touch all our lives?
Okay, so my group develops and researches technologies that help bring the power grid to life. So we will do anything from your traditional generators, nuclear plants, coal plants, obviously solar, wind, other renewables, and figure out how to best get the power from those sources onto our power grid and eventually deliver power to our homes. So the people that I work with every day deal with everything and anything that helps you get power to your video games, to your, your
toaster,
computer, your
to
toys.
microwave.
Absolutely.
This is a really, really big network. When we talk about the power grid across the United States, across Canada, this is pretty big, isn't it?
Absolutely.
Can you give us a sense of just how large it is?
So you can think of it as basically one big machine that extends over the entire country or the entire continent and allows you, through the use of wires and other technologies, to move power around in a very large and complex system everywhere from California to New York City.
Okay, well, on that note, we're going to take our first text question. And this one is from Ashley. What do you do on a normal day at work? What's a typical day at work for you?
So pretty much I get to work in the morning and I start talking to most of my global colleagues. I have colleagues in India, in China, in Brazil, in Germany, in California, and we generally I start out the day by talking with them, seeing what happened in what was overnight for me and what's their daytime, and then I start having meetings with local teams and local groups, and we talk together, solve problems, figure out what the next technology is that we need to work on it, talk about and brainstorm ideas of how to solve the problems that we're seeing. And
why are you talking to folks halfway across the world anyways on a regular basis? How are you guys connected?
So we, GE, I work for the GE Global Research Center, and we have offices in all of those places that I mentioned. And depending on why or what the problem is, we're talking for different reasons. But for example, in Germany, they've installed a lot of solar power, much more than I think pretty much any other country in the world. So for me to be able to talk to my colleagues in Munich about the problems that they've seen or the solutions that they've found to integration of high-scale solar into the power grid is an advantage that I have. Because
so it's really about trading secrets and sharing experiences
Absolutely.
And stories and learning from other people's mistakes and their successes, I guess.
Absolutely.
Okay.
Yes.
Another text question for you now. Talia would like to know, how does engineering fit into renewable energy in the real world?
Oh, okay. So the renewable energy field encompasses all sorts of different types of engineering. You have people who are electrical engineers like myself that deal with the electrical part, anything from how do you make the motors inside the wind turbines, how do you deal with the conversion of power from rotation to electricity. You have mechanical engineers who deal with the blades, the wind towers, making sure everything can handle the wind loads.
And there we're seeing a turbine go up. My gosh,
Absolutely.
that looks like a jet plane or something.
Yes, it
Huge.
does.
Some
Yes.
of them can be as tall as 20 stories high. And
Right, yeah, about 100 meters tall, I think, is a typical.
whoa, I'm getting dizzy just watching that.
GE
Okay.
wind tower,
And
yeah.
the blades, they're so large, some of them. They can span the length of a football field. Is that true?
Absolutely, yes.
Wow. And so the bigger they are, the more power that they can potentially generate?
Sure. Generally speaking, the radius that the wind turbines have, or the
blades?
diameter of the circle, or the circumference of the circle that is made by the tips of those blades, relates directly to how much power the wind turbine can get out of the wind. Yes.
Wow. All right. We've got some more questions for you, and this one is: how is your job specifically related to renewable energy?
Right. So specifically, my job has changed a lot over the years. Actually, a couple of years ago, I was directly developing technology that would help solar be able to deliver more power to the power grid. So we're looking at, making sure that the solar does not cause voltage fluctuations, and how can we increase the amount of solar that goes on a certain area without causing any issues. Then I took over running this power systems group, and there I broadened out, and I was looking really at anything from large wind turbines, how do you get that power onto the grid, how do you move that power over very long distances.
Right, because where it's windiest and where those wind farms are isn't necessarily where the demand is, like where you need them, the cities that are
Absolutely,
hundreds or
yes.
thousands of miles away.
Right, absolutely.
Okay.
So that's a big part of what I do. And now I work, just most recently I changed to a new job where I'm dealing more with technology development strategy and managing large groups of projects that are all focused somewhat in the same region. A lot of that work is renewable as well.
You keep moving. You just keep
yes.
moving. Okay, and we're going to keep moving. This is our next text question from Jesse. What is the best thing about your job now? And what is the most difficult thing about your job now?
Okay. I think two of the best things about my job, one of them is I get to work with people from every different technology field. So the area, or the place that I work at has scientists and engineers, everything from biology, chemistry, physics. You can meet and talk to in a single day people from all different walks of life. The other thing, though, that is really good is that I feel like I'm able to really focus on strategy. So, not only how do we invent things that will do this, but what do we need to invent next? What's coming around the corner? What's the next thing that we're going to need?
And what is that? What are you seeing
If I
so
knew
far?
the answer, I would.
You'd be out of a job.
Yes. But, it's really.
Is there a big trend, though, that you're seeing in terms of energy technology?
Yeah, you see more renewables, certainly, and you see wind being focused more at a large scale level. Solar you see on residential rooftops. You see solar really spanning everything from a residential installation all the way up to, huge multi-megawatt fields of solar PV.
Yeah, and I've seen some of those images, and we might see them throughout today's program, but they're just massive.
Absolutely.
Yeah, these panels that,
Right.
gosh.
Acres and acres of
Right.
solar panels.
Oh
yes.
my goodness. Okay, we're going to go to our first poll question of the program. You guys ready for this? Which of the following is not considered a renewable energy source? Is it A, wind, B, solar, C, natural gas, or D, geothermal? You've basically worked in all those fields, haven't you, at some point or another?
Yeah, absolutely. I don't, and my group does certainly not necessarily develop the machinery that is, taking the power from those sources to the grid, but we do definitely look at how you integrate each one of those. And they really all act and react in a different way. So there's different schemes and algorithms you need to integrate each one of those sources.
Is there one in particular, one renewable in particular, that seems the most promising, that will be sort of the front runner, the one we're most likely to see in the future see a lot of in the future?
A lot of that depends on incentives that different governments and different groups decide. But right now we're seeing really wind is out there, and it's making gains very quickly. So I would say wind right now is...
Wind is looking very promising. All
Absolutely.
right, for those of you out there thinking, what field will I go into? Possibly wind farms may be springing up quite a bit
Absolutely,
down the
yes.
road. Okay, the poll results. Well, it turns out that most of you picked natural gas, and that is the correct answer. That is not a renewable resource. It is, however, if you think you wait another 27 million years, we might be able to regenerate some more natural gas. But that is the correct answer. Good for you. In this program today, we've done something kind of neat. I think it's kind of neat. We're not only going to talk to Kathleen about her fascinating career, but we also wanted to introduce you to other types of jobs in the renewable energy field. And so we sent a camera crew out into the field earlier this year to talk to a whole roster of working professionals in the wind industry. Right now we're going to meet Ray. He's a wind turbine technician, and here's what he had to say about his job.
My first thought of him was, wow, that's huge, you know, it's pretty magnificent, that's for sure. My name's Ray O'Brien. I'm a wind technician here at Stetson Mountain. I'm also the environmental health and safety coordinator here at the site. A lot of people joke around and say, you know, this is a view from my office, and you know, it is a view from my office. I spend a lot of my time up here. I make sure everybody is up to speed on safety. I do all the harness inspections and making sure the equipment is de-energized and there's nothing electrically or mechanically that can harm us as technicians while we're working on the equipment, and pretty much just make sure everything is going smooth on a day-to-day basis. Well, it's actually an amazing job as far as you're not coming up and doing one thing every day. You know, you're not coming up and just doing electrical work. There's numerous systems in the turbine as far as there's hydraulics, there's the mechanical system as far as the gearbox moving. You do have your AC electricity, you have your DC power, you have communication, whether it's Ethernet or fiber. Every day you're not working on the same piece of equipment over and over, so it's really good in that aspect. Really the toughest part is dealing with the extremes as far as really cold temperatures. Some days we come out and it's -10, -20, and depending on what the wind speeds are, you know, you're looking at wind chills that are -40, -50, sometimes worse than that. From day one, I've always been the type of guy who likes to tear things apart and put them back together. If something's broken, tear it apart, see how it works, put it back together, make it work again. That's really what drives me as a technician. I love tearing something apart, putting it back together. It's something that I love to do, and that's part of the job. Based on how the oil reserves and fossil fuels and all that's going right now, it's, you know, good to have wind power, and I just see this as being, you know, a start of something big. It seems like it's something that's going to be here for a long time, and I'm hoping it is.
Now that was a cool view, wasn't it?
Absolutely.
Can you imagine an office like that?
Not for me, no.
Right, you kind of got to not be afraid of heights to do that
Exactly,
job.
yes.
That was a really cool look at Ray's job, a wind turbine technician. So he talked a little bit about how he got to where he is. He knew early on, hey, I have this thing, I love to take things apart and put it together. Did you have an inkling early on that electrical engineering was where you wanted to go?
Not at all, no. I did not. I certainly, you know, have put things together, taken things apart, but really for me early on, I had no idea whatsoever that that would be my career. And I, you know, sort of it was through a lot of twists and turns that happened along the way that I ended up here, but I, as a child,
well,
was
there
not,
you, is that you right
yes,
there?
that is me and my cousin playing with a...
With like a racetrack
yes,
or something.
Exactly.
Huh.
Yes.
Obviously a really important experience that led you to electrical
Absolutely,
engineering.
yes.
You had to play with racetracks.
Yeah.
Very interesting. Well, on that note, we have a video question coming to us now from Hannah and Olivia.
Great.
And yes, it's very related.
Hi, I'm Hannah. And I'm Olivia. We're from St. Philomena School in Peoria, Illinois, and we were wondering, why did you choose to be a power systems engineer?
Oh, okay, great question. I really, as I said, I sort of went through a lot of twists and turns to get here. I went to college and I thought I'd try out electrical engineering, and I turned out to be okay, pretty good at it. So I graduated and I went to work actually for a company that makes submarines, and I did a lot of work for a while on an electrical submarine system, which is close but not exactly the same thing as I do now, or as power systems engineering. After that, I worked on some other pieces of equipment, some other electronics, And then I started talking to people in the field just through work and just through, having gotten there. And I ended up, working in this area in a much more in-depth way and sort of, figuring out about renewables, about the potential, about the complexity of the machine, all of that sort of
drew you to that,
yes,
that
absolutely.
sector. Well, it's kind of sounds like it's a little bit of trial and error. You kind of go down a certain path. You think, you do it for a while. Do I like it? Not so much. Move on to something else.
For me, certainly.
But you find
yes.
your passion. You have found
yes.
your
oh,
passion.
absolutely. Yes.
We've got another text question for you, Kathleen. This one's from Jim. What did you major in college? Is there any specific majors related to renewable energy that I can relay to my students if they're interested?
Yeah, okay. So I majored in electrical engineering in college, but as far as careers in renewables, there's a lot of majors that you can use to work with renewables. So just a few I can think of, certainly mechanical engineering, physics, especially, I have a lot of friends who are physicists who work on the solar module. Chemistry, when you're looking at batteries that can be used to store the energy.
And I guess chemistry would come in handy even when you're looking at solar panels to some
absolutely,
degree.
yes.
Because you got to think about what are they made
right.
out of.
And material
so on.
science is huge too. You don't have to be an engineer. There's a lot of scientists involved.
Great. Some good choices there for you.
Absolutely.
Lots to think about, lots to take in college. Lots of homework too.
Lots of options.
All right, we're going to take a video question now. This one is from Matthew.
My name is Matthew, and I'm from St. Philomena School in Peoria, Illinois, and I was wondering, what experiences did you have that contributed to you wanting to have this career?
Oh, okay. So I think one of the big things for me, early on was, honestly, I wanted a career that was solid, that, gave me a good financial future and everything else. But later, when I sort of got into the specifics of renewables, it was really, I started to have kids. I have 4 of my own now. And thinking about their lives and their careers in the future and what I hope the world will be like when they're adults. This really is a career where you can make an impact like that. And so that's sort of what refined it for me.
Mm-hmm. Clean energy is sort of
absolutely.
the future. Okay, another text question. This one is from Ms. Randall. Why should someone go into your line of work?
Well, everybody has a different reason for going into, every different line of work you can think of. Some reasons I can think of, certainly you have the potential to help the environment, help us have cleaner energy mixes, give our, the youth of the world a brighter future, but also, frankly, you get a great chance to work with people from all over the world in all different technology areas, do some cool things, use some really interesting machinery. You get to see things no one else sees and do things no one else has done, and it's an opportunity to discover things that no one else has ever built before, and that's awesome.
Wow, that does sound cool.
So many different reasons.
That does sound cool. I think you gave us a good bunch of options there. So we're going to take it to the audience right now. We want to know what you guys think of this. When Kathleen was 12, she dreamt of pursuing this career when she grew up. Was it A, lawyer, B, historian, C, astronaut, or D, nurse? What do you think Kathleen dreamt of becoming when she grew up? They all sound like they could possibly be right. I don't know about the nurse personally. I don't know if I see you in the nurse thing. You did drop a few hints along the way. What is the correct answer?
The correct answer is historian.
Oh, historian. Of any
Absolutely.
specific time period or
At the age
20th
of
century?
12, it was sort of Middle Ages Europe. That was my fascination at that
right.
time.
Well, the results have just come in. I'm just getting them in my ear. And lawyer and historian and astronaut are all tied. Is that right, Pat? Okay, Pat is our producer, and he's off to the side in the control center, and he's just telling me that you all equally voted for lawyer, historian, and astronaut. Wow.
Yes.
You're giving off lawyery vibes and astronaut
I guess,
vibes.
yes.
The historian, do you see any connection at all between your love of history and your love of electrical engineering?
So absolutely, as odd as it might seem, I think that my interest in history really came from trying to figure out and understand, like, how did we get where we are today? What were the historical forces, the societal forces, the inventions and innovations that caused us to be where we are today, and how did that unfold? And I think that interest helps me to sort of now I'm looking at the future. What are we going to be like in the future, and what technology do we need to invent to get there? And it's really sort of one continuum, one path along the way that, in my mind,
Right,
that I
to
see.
know where you're going, you kind of got to know where you came
Absolutely.
from.
And why and how it all shaped together. And I think that really helps me sort of think about strategic technology development in the future.
Okay. We are going to take a look at a couple more career profiles now. We're going to head back up to northern Maine, the remote wilds of northern Maine, where Pat and some of our team went to film some of this. And we're about to meet Troy and Bill and Dave and Jacob, and they help manage and operate a wind farm there called First Wind. Let's take a look at what they do and why they're so passionate about their jobs.
At Stetson site, we have 55 1.5 GE SLE turbines, and they span over a ridge that is approximately 4.5 miles long. With 2 people keeping the place running, it takes a lot of man hours, and we're busy the whole time that we're here. My name is Troy Cameron, and my role here at First Wind is Assistant Operations Manager.
We work in an industry that's got electrical, it's got mechanical, it's got hydraulics. There's so many things that you can do in this industry. Tomorrow you'll be doing something different. My name is William Hare. I'm the operation manager for all the main sites.
As an Assistant Operations Manager, I oversee the day-to-day site operations. It is a lot of different things that we have to do. We have to be safety conscious. We have to be environmentalists. We have to be supervisors, accountants, good with equipment. We have to be mechanics, electricians. It is a lot of responsibility. There are a lot of things that can happen day to day.
You don't have to sit in an office every day. If you tomorrow want to go out and do some road work with Troy, I can go out and do some road work. I think that's why people really like the wind industry. Clean energy industry, I can only see it getting bigger.
The more renewable energy we have and the resources that we have, the better off the environment is going to be in the future.
My name is David Grant, and here at the Stetson Wind Farm, I'm a wind farm support specialist.
My name is Jacob Terrio, and I work at the Mars Hill Wind Farm as a wind farm support specialist. Being a wind farm support specialist, your responsibility is taking care of all the site vehicles, the maintenance records, the maintenance logs.
We do everything from snow plowing on the roads to repairing the roads to inspecting the high voltage facilities, cleaning the building, repairing the building, maintaining the building. We do maintenance on the site. We inspect the roads and maintain them. We do some work in the turbines, which is basically usually inspection work.
I would say my favorite thing to do is climbing turbines. That never gets old. And you walk in and you got your harness on, you got your hard hat on, and your safety glasses and your gloves, and then once you get up and you can look around and stand up, words can't describe.
When the wind farm is operating, the turbines produce electricity which is sent out to the substation. In the substation there's a variety of transformers, breakers and relays, which we monitor for any kind of damage, any kind of misoperations, to make sure they're maintained in an operating state. So at any point in time, if there's any problems with the lines, we can open and close those circuits to stop the flow of electricity in or out of the park. My favorite part about working here is that I actually get to spend approximately half my time doing office-type paperwork, but I also get to go outside and do about half my time in the outdoors, which I'm a big outdoorsman. I've always loved being outdoors and working outside.
Working on a wind farm, you can expect anything to happen. You got to be up for anything. You come in the morning and you got a turbine down and you're needed to go climb. And so you could have a plan in your head and it could be changed really quick.
Well, if that job doesn't keep you on your toes, I don't know what does.
Absolutely.
I mean, one minute you're out in the woods, and then the next minute you're out there doing something computer-oriented. It sounds really challenging, but fun. You can see it in their faces, like how excited they were to talk about it. What are you interested? I'm curious about what you sort of see for the future. I mean, we talked a lot about wind farms. Is the future looking bright for renewables? Are we going to ever have renewables be more common than fossil fuels as an energy source, do you think?
So I think that's absolutely possible. We sort of have to decide as a society where we want to go with it and what we want to do, but we see countries like Ireland and Denmark where they've really, they're pushing the boundary and they have a whole lot of wind on their system, and they're definitely getting much closer to that. So it is definitely a possibility for the future.
It's a possibility. Okay, we're going to take our first video question, and here it is.
Hi, I'm Grace from St. Philomena School in Peoria, Illinois, and I was wondering, how will wind technology revolutionize how we will live in 10 years?
Oh, that's a good one.
Yeah, absolutely. So I don't know if wind energy will actually revolutionize the way any one individual person lives in 10 years. I think really the goal is to have more wind generating more of the power that we use every day in our life. So, we want to make sure we can maintain the same amount of energy delivery. We want to make the grid as reliable as it is today and as robust as it is today, but with more wind on it. I think, though, one of the ways it has a potential to transform our lives in 10 years is just by the amount of information people have, or the amount they see wind turbines in their area. They know what they do for the grid. They get a more robust feeling about how energy is delivered and used, and that should make all the difference in the world.
If you see wind turbines around, it's not such a rare thing. You start to learn about them, you become more educated about them.
And you ask questions about your energy environment, and that leads people to make different decisions. So I think that's probably the biggest way it's going to impact everybody's life.
All right, good question. We're going to turn it now over to Frank, who has a question. In the Department of Energy National Renewable Energy Laboratories Renewable Electricity Futures Study, they concluded that we could achieve 80% renewable energy for the electric sector by 2050. That's just 37 years from now. So in your opinion, how should the nation's education systems prepare its students for this national challenge and opportunity? That's a really good question, which is exactly what we were touching on.
And that's an amazing study. I've read it myself. It's great. I think it's a very complex question, right? But in general, engaging kids early so that they understand what the potential is of this is a big deal. I think, obviously science education, math education, but also really letting students know and understand all the different ways that, and all the different skills that are needed to make this future that's described in that study happen. So it's not just science and math, which is obviously very important, but also, if the guy that finances the wind plant isn't there, this isn't going to happen. If the person that communicates it to the audience or the community isn't there to explain what it's about, that's not going to happen. So I think we need to look at all the different areas that are needed to make this future happen, and then let students know early on that this is the future. But there's so many amazing educators out there that work in this field every day. I'm certainly not one of them, but I admire them all.
You're doing a great job.
And I think they will help us get there if we talk to them and engage together between the renewable energy industry and the educators today. We can make that future happen.
So it's really about a dialogue and a conversation. Okay, and next text question from Andrew. As solar panels and wind turbines improve, I don't see battery technology keeping up with their improved output. So what's cooking in the labs in terms of battery capability?
Yeah, so in the research center where I work at GE, we have entire groups of people that are dedicated to this question, that are making battery cells today that we're actually just bringing to market that can help with this, but also looking into the absolute, limits of technology today and looking at what can we develop in the future. So I'm not a chemist, I'm not a chemical engineer certainly, but we are looking at different batteries that store energy better, different batteries that store power better, batteries that are tailored for their exact use.
So bigger, better batteries, not bigger physically, but just
absolutely more energy
batteries.
Dense. Yes, absolutely.
So it is being worked on. Okay, great question. Nathaniel, what is being done to educate people on wind energy?
Okay, well, I think there's a whole lot being done to educate people. I think, everywhere from our our universities, our high schools. We're teaching what does it mean, what mechanically, how does it work mechanically, how does it work electrically, how do you get a job as a technician inside the wind turbine? We saw some of that earlier. I think
and even conversations like this, which start to get people thinking about renewables as a career.
Right, and even just in recent years, when I was growing up, a lot of my friends went to community colleges to become electricians and work in the automotive industry. Now I go to the community college in my neighborhood, and you can actually get entire degrees in being a technician on a wind farm or working in a solar plant, and that's something we haven't seen before. So
we are seeing a bit of a shift. How interesting, yeah.
Absolutely.
Okay, another text question. This is from Ron. What is the future of solar power as an alternative power source? So right now in the big picture, solar power takes up about 1%
in this country, yeah,
of all the energy that's produced
yeah,
in the U.S. What do you see down the road?
So I think it's growing. Again, it depends a lot on what we as a society decide we want as our mix. Some states are asking for more solar, some states are asking for less. I think it absolutely has a huge potential. We see the price of the solar modules coming down. That means they're more affordable and people can use them to produce more power than they had in the past. And there's also other kinds of solar. It's not just the PV panel you see, there's solar thermal, the ability to make power from the heat generated by the sun, not just the light.
So once solar becomes a little bit more cost-effective or cheaper to produce, we're going to be seeing a growth in it.
I think we're there with the cost. I think we just are. When we're seeing a big boom, obviously there's always further you can go with cost, but it's growing. It's getting there.
Growing.
And it is certainly not going away. If you look at the U.S., it's a very small piece. If you look at Germany, it's absolutely huge.
Right.
So
in proportion to the amount of sunshine they get. It's
absolutely.
not that sunny over
it's
there.
Not
We got
that
lots
sunny,
of sun.
But they have a huge solar industry.
Yeah.
So
there's a lot to take advantage of here.
Yes.
Okay, another text question, this one from Anupam. Is there any possibility of developing wind farms in a big populated city for energy generation? That's a picture. Imagine having a wind farm in
New York City. So certainly it's technically feasible to do that. And in many cases it might be actually easier from a power grid perspective because the people who are using the power are located very close to the wind farm in the case that it would be in a big city. The things that cause people to generally not put them there are, the cost of land and the value of land in a big city is much greater than it is in a remote area, which makes the whole cost of the plant itself much higher in a city. But also, cities aren't necessarily located in the windiest places, and you definitely want to put your wind farm in a windy place. So there's some reasons behind it.
Are there any environmental impacts, just very briefly, that we need to be concerned about when it comes to wind farms? Because look at that, it's just gorgeous. But they're big, they take up some space. Some of those wind farms are miles long.
Absolutely, and in certain places people have decided that they don't want them, and in other places they're very welcome. So it really depends on where you are, and again, what we as a society decide we want as far as power generation. So certainly any method of generating power is
going to have some side effects. So I guess with wind, we'd be talking about noise, a little bit of wildlife safety, those kinds of things.
Yes, although we are developing and continuing to develop technologies at the research center where I work to try to minimize those impacts.
And that's another field to specialize in. Good to know. Okay. We are going to talk about another career in renewable energy. This one is something you haven't seen so far. We're heading up to Boston, Massachusetts to meet Matt and Pavan, who work in First Wind's Distributed Asset Control Center. It is a control center, but what exactly do they do there? Let's take a look.
I'd say an exciting day in the DAC is what we like when there's a lot of wind. My name is Matt Forrest. I'm the DAC manager here, and DAC is Distributed Asset Control Center.
Distributed Asset Control Center, and that's the eyes and ears of the company. My name is Pavan Kumar Dhavaleshwar, and I work as a senior DAC operator, and what we do here is control and monitor wind farms all over US.
We run 16 wind turbine sites with 540 turbines, almost a gigawatt of electricity. In the control center here, we have our monitoring screens that the DAC operators use to maintain an overview of 540 individual generators. They're looking at turbines on a real-time basis. We can help predict what's going to happen with a turbine. The DAC operators make a lot of decisions to determine what is safe and what is not safe, and they coordinate with the site operations teams and the site turbine managers to make the right decisions on a daily basis.
We have control capability. We can shut down the whole fleet at one click. We can shut down the turbines.
We can operate the components in the substation and coordinate with the utilities and the balancing authorities that run the electrical grid to make sure our electricity goes out into the grid without a problem. It's a very complex job that requires your brain to be engaged full time. It's more than just turning a switch. It's asking yourself, what's going to happen if I turn the switch and I don't get the expected response? What are 3 or 4 likely scenarios that are going to could possibly happen besides the turbine starting up correctly, and what am I going to do for each one of those? Those kind of things have to be going through the operator's head every single time they start a piece of equipment.
It's pretty fast paced. We tend to feel overwhelmed and try to get panicked, but we have got used to it. And coming from the background I come from, I really enjoy that part rather than sitting idle. That really comes from good time management skills, multitasking, end of the day getting the things done in a safe, secure manner, and in a manner which really impacts the company in a positive way.
When I was in high school, I didn't know that I was going to end up doing anything with power generation. I kind of knew I liked physics and math, calculus, whatever it was, anything to do with engineering, mechanics. I like to build stuff. I like to do hands-on things.
And I really like this industry once I got into it, mainly because of the value it adds to the environment, it adds to the society. And once I started getting more involved into it, I really started liking it. It's because it's always changing. So there's something new you can add every day.
Wow, wind farms are growing fast and furious in this country.
Absolutely. Yeah.
What is the reason for that? Is it just because they're just more efficient than they were in years past?
Oh, some of it is renewable energy portfolio standards, which are laws or rules states make because they want to have more renewable energy and they incentivize people to do that. Some of it is because of cost, certainly. Some people make money, obviously, off of building wind turbines. There are incentives that are given by the government. But really, more and more, we're seeing that, wind is profitable even without government incentives. So we're starting to turn that corner and really make wind stand on its own and be a real part of the...
There has to be that economic incentive, and then it makes sense.
Of course. I mean, everybody does everything, in a business environment for a monetary reason. But with help and technology, we can really make it make sense for a lot of people.
All right, make it viable. Okay, our first text question in this segment, Nathaniel, how many jobs are available in the field of wind energy?
Wow.
Do you have any idea?
I have absolutely no idea, but I'll tell you it's a lot.
Yes.
So I think, there are a lot of different types of jobs, and certainly probably a resource like AWEA, which is the American Wind Energy Association, would be able to tell you, a much better number. But within types of jobs, as I said, that you can be in the wind energy industry by being a finance person that looks at how much money a plant is going to make and whether they deserve a loan or not. You can be someone who is a communications person and writes stories about wind. You can certainly be a person who develops wind turbines, who integrates those wind turbines into the grid. There's just so many different options.
I know, there's so many. I've come across a little number here that says that for American wind farms in general can basically create at least jobs for 75,000 Americans.
Yeah, even
that
just
sounds like
that's
a lot.
just the wind farm operation probably itself. So you saw some of those wind farms in the videos we saw. Those guys work there. I mean, that's a full-time job for many people just to keep it running. Not to mention all the jobs it takes to, design the stuff and build it and hook it up. So
and
a
that's
lot of jobs.
Just one estimate. Okay, we've got another text question. Mrs. Amris's third grade class. Can you explain to us what are the important factors in making decisions about which power sources get to access the grids, when they get to use them, why they get to use them, and how? Oh my gosh, what a great question.
Okay, so I'll try to remember the entire question. So, when we make decisions about which type of power gets to connect to the power grid, a lot of time it's about rules and regulations that have to do with the governments and the decisions people make. It has to do with where resources are located, where it's easy to get access to those resources. And then it also has to do, obviously, with where does the circuit, where does the wires that make up the electric grid, where does it make sense to do that? It has to do, obviously, with profitability. People who own power generators, regardless of what type, are generally, and not always, but generally they're building and maintaining that plant to make a profit. So it has to do with that. And it's a lot to do with decisions people make as a society. And different utilities in different parts of the country have different rules and regulations that go into that. But you know, if you're interested in that and that's something that's important to you, you can get involved in your community and start having those conversations.
And in terms of the big picture, right now, still most of the energy that we produce in the U.S. comes from fossil fuels, a big chunk.
Yeah, a big chunk, nuclear power as well.
But renewables is growing.
Absolutely.
Yeah, it's about, what, 10, 12%
I think
of
it
the
depends
energy
how you
produced?
measure it. But yes, as far as energy produced in the country in a year, I think we're at around 15% renewables. A lot of that is hydro. So the big dams that have been around for a long time, you see those especially in the west and northwest of the country. But wind and solar and other types of renewables are definitely gaining.
Are coming up, okay. Do you have any final thoughts, any words of advice you'd want to give to the folks out there who are listening thinking, you know, I might want to get into this? Is there anything?
So I would say, you know, there's a lot of different, as we talked about a lot, there's a lot of different paths and a lot of different ways you can get into this. And there's also a lot of different fields of science and math and engineering outside of just renewables. So if you're interested and you want to know more and get to know the different career paths of some different people, we have a blog at the research center where I work called Edison's Desk, GE Research. You can look there and you can virtually meet on the internet a ton of different scientists, engineers, and mathematicians, and see how their career paths were and what their roles are and why they got passionate about what they did.
The blog is called Edison's Desk. You know what, everybody? We've had such a good time. I don't think we realized that we ran out of time. Thank you so much for joining us. Fantastic questions. Really got a great conversation going. And we've got to thank Kathleen O'Brien for joining us today and for giving us this amazing, inspirational story.
Thank you.
I think a lot of young girls and young boys out there are thinking about this a little bit more today. And I wanted to let you know as well, if you're interested in energy and topics related to energy, the fun doesn't have to stop here. You can always go to Transform, Connect the Future. Transform the Future, rather. I want to switch those things around. You can connect, Transform the Future, and that's a project that you'll find on the National Geographic Education website. That's natgeoed.org/connect. A ton of online resources designed to help kids from grades 4 through 12 think about energy and energy solutions for today and tomorrow. Plus Planet Green, The Big Switch, which is a very cool online game that you guys can try out as well. For everybody here at the Jason Live team, Pat, Melissa, people you can't see in the control booth, Sean, and Kathleen, of course, thank you so much for joining us. I'm Patty Kim, and we'll hope to see you next time. Bye-bye.